My website is down for an hour every October for the last 20 years. And at least I know it, though. You know what I mean? At least I'm aware. Like, Raygun tells me the line number. One day I'll fix it, but it's only cost me 5 hours of downtime over the last 5 years. I figure I'll put 5 hours of work into it in the future.
Well, you hit on an amazing point that a lot of the things with these tools and why it's often better than a generalized logging solution is what actually matters, and building a workflow where you can ignore some of the things that really aren't a big issue, that you've triaged it and gone, you know what, not worth the time, versus ones that actually this is costing us revenue or, customer satisfaction.
That's a great point. I've got one bug live on my blog right now. When you visit the directory of my where my graphics are stored, it throws an error. It throws an error in a static file handler somewhere. But you shouldn't be doing that. You're probably poking around. It doesn't affect the end user. So I can go into Raygun and I can say, ignore this class of bug. I can snooze it, like hit the snooze alarm, and then I can worry about it later because it's noise. And that allows me to not just see my bucketed bugs, but really focus on the high priority ones, which is nice.
Yeah, everything in sort of crash reporting is about how do you improve that signal to noise ratio so that you can be as effective as you possibly can as part of a high performance software team.
That is what it's all about. I can send you 1,000 log files and say, go and figure out what the right business decision is, but I can plug it all into Raygun, and Raygun will tell you, here are the bugs, here's who they're affecting, here's how it's affecting them. You pick the ones that are high priority, you link them into your bug system, and go to town. It's fantastic. And folks that are listening can sign up at raygun.com. You can have this experience in your software. You can find out where the hidden bugs are, and you can decide to ignore them. Check it out, trial at raygun.com. Hi, I'm Scott Hanselman. This is another episode of Hanselman Minutes. Today I'm chatting with Ted Neward, longtime principal of Neward & Associates and also a guest lecturer at places like the University of Washington. How are you, sir?
I'm doing well, sir. How are you?
I am very well. I haven't talked to you in a while, but what I do like talking to you about is history, because you and I have been around a minute, and we've known each other for, I want to say 20 years, but I haven't done the math.
I think it's definitely 20 years. I think, I can't even, you're one of those people, Scott, that I literally cannot remember how we met. It just feels like I've known you like forever. You know what I mean?
Aw.
Yeah, I know, right? I mean,
probably through Developmentor at some point, somewhere from the Don Box days.
Well, yeah. I mean, I was a part of DM back starting in 2000. And, of course, DM was front and center in the whole .NET thing when it got spun off.
Mm-hmm.
So I imagine it was through, one of those, you were at a show, I was at a show, somebody said, hey, Scott, this is Ted. Ted, this is Scott, kind of thing. Or we were just hanging out.
Right.
The other memory I have is you were part of the RD program for a long time.
Right. The RD program is regional directors. It's kind of like the Microsoft, it's a Microsoft influencer program similar to the MVPs.
Right. I never became one, but I was hanging out with many of those folks. And so I imagine we probably connected through some get together. We probably had dinner together and just don't remember.
One of the great kind of like joys of my life has been sitting in the Hilton lobby after a conference. We always call that the hallway track, right? If you ever, for our listeners, if you ever have the chance to go to a conference, there's the going and then there's the attending, but there's the hallway track, and it's such a joy. And just sitting in the lobby of whatever hotel is the hotel for that conference and hanging out and just vibing, whether I've met people like Rob Connery in places like that, or Grady Booch. I've met people like Angie Jones, just like holding court in the lobby, and you just learn as much as a session. Yeah. And that's kind of what I've tried to do with the podcast is pick people's brains the same way that I would were we in the lobby of a hotel in the middle of a conference.
The thing about the hallway track that I think a lot of people who've not been there, it's not all work, right? So often it's about, connecting with people and you talk about stuff, and at least amongst the speakers and frequent conference attendees that I hang out with, half the time we're making jokes, but the other half the time the joke leads to a question, leads to a deep conversation. There's all kinds of interesting things that happen during those conversations. And it's totally unscripted, right? There's no plan. There's no rhyme or reason to it. But you get just the most interesting insights, the most interesting stories, and stuff that, frankly, if a conference speaker had thought to put it into an abstract and propose it, conferences would never take, because it's all, you could never script some of it. It is the thing, I think, that makes conferences so attractive compared to just sitting sitting in front of your computer watching YouTube all day. I mean, it's such a different experience when you can sit there and talk to people and vibe with them.
Yeah. I got my start in, really just going to user groups, because there are introverts that get energy from being home, and there are extroverts that get energy from going out. I'm kind of an omnivert or an ambivert. I can kind of go back and forth. But when I was starting out in the early 90s in software, but back in the 90s, you recall, Ted, there were only like 2 books, right? So you had like the KNRC book, and you had like whatever, Code Complete, and you sit there, and if the answer wasn't in those books, you were basically stuck, and you have to put a message out on the FidoNet or CompuServe and wait a couple of days until, maybe Knuth sent you back a couple of pennies and a check. That's basically, there was no other way to do it, right? So I would go to these user groups and ask questions of my, for lack of a better word, my elders, whoever the folks that were running the event. So for those that are listening, I would encourage them to, get out if you're able to get out, whether it be virtually in a Discord or hopefully physically at a user group or a local code camp. That's where the energy happens.
Yeah.
I remember actually, I gave one of my very first talks ever was on XML. It was literally called Introducing XML.
Nice.
So that's kind of that's when I was really thinking about data. Select star from tables, and here's a pile of XML. Where did you start in the data world?
Oh my gosh. For me, I started programming professionally in 1994. So it's been a hot minute, 30 some odd years. And I was working for a small startup that was going to take on SAP, and they were using C++ and they were using Oracle for their backend storage. And that was my first professional exposure to Oracle. And I didn't get it. I mean, I was so used to writing C++ code that was writing things to local files, right? So you open the stream, you write some data, you close the stream. This is how this works. And I just didn't, where does it all go, right? And I think what a lot of people today don't really understand is just, how thoroughly the relational database world conquered the world of data storage, such that the idea of, there are people in the world who grew up not necessarily assuming that data was always going to go to a relational database, right? And I suppose I should qualify this, right? Because when I teach college students today, a lot of them are very embracing of the whole, NoSQL movement, right? They, oh yeah, you can store it in a document using JSON, you can store it in a graph, they got all these different options. But the generation prior, and to a lesser degree our generation, it was always a relational database. That was just the only option. Suggesting anything else was technical heresy. Don't do that, right? You don't have the reliability. Do you remember the object database phase?
I was at Nike in 1997, 98, and we were talking to a big iron machine from a giant Linux terminal, and someone was like, object databases could change everything. Like we don't need this thing. We'll do this other thing. It was the shiny thing. But I wanted to make a point, though, that you talked about, you wrote in C++. So around 96, the Palm Pilot came out. Mm-hmm. So I wrote a blood sugar management system on the Palm Pilot in MetroWorks Code Warrior C. And it was just, where I needed a database, right? And here we just take SQLite and we just throw an embedded, we literally take an embedded SQL database for granted, bring it in as a package. But back in the day, it was an array of C structures packed down to the byte because I only had 4K, right? And why did I need a database? Well, at some point, you needed to query that. So now, am I just for looping over thousands of blood sugar records? But I can't run a database on a Palm Pilot. So that is a fundamentally, like, when you come up born that way, when you're wired that way, and then they introduce structured query language, SQL or SQL. I wonder how it changed our brains versus people for whom JSON and NoSQL databases just existed always.
Well, to some degree, you and I think, grew up in a time when, the operating system was always there. But there are developers who came in a generation previous to us where, you wrote straight to hardware, right? You wrote your own operating system. You managed your own interaction with the hardware as opposed to going through device drivers and so forth. The interesting thing that I'm finding right now is we are, so relational databases, they kind of conquer the world, so much so that object-oriented databases kind of never got off the ground, even though they were a hell of a lot easier to use, from an object-oriented programming language. When the NoSQL revolution comes around in 2000, a lot of people said, oh, okay, no, this makes a lot of sense, because now I can get away from having to do schemas and what that did in some respects is kind of opened a Pandora's box, if you will, where now all of a sudden people are starting to play around with not only the shape of the data that you're looking to store, but we're also looking at potentially having multiple shapes, right? So I've been talking for a while with the folks over at Couchbase, hang out with them at various conferences. Matter of fact, I just did Kansas City Developer Conference not too long ago and did a talk on NoSQL. And Matthew Groves, who is one of the Couchbase evangelists, advocates, I forget what, or maybe he's just in developer marketing, I forget. Anyway, he's there in the audience, and so I borrow him for a couple of examples walking through some of this stuff about databases and so forth. And there are a number of things that we kind of assume come as part and parcel of a database. The shape of it's always relations, the strongly typed nature of the data. In other words, it has schema and the schema is enforced. The fact that we use these characteristics to ensure that the data is always consistent and available. When Eric Brewer wrote his CAP theorem paper back in 2000, where he talked about consistency, availability, partition tolerance, pick two, it really opened up a lot of questions like, hey, okay, so maybe we change when and how we store data and when and how that data is changed and made available and so forth. And it just all of a sudden opened up a whole raft of questions for people to say, wait, maybe we don't need to do it this way. We don't always need to store it in relationships. We don't always need to do so using transactions. And we're still feeling a bunch of the effects of that today, where we can change storage engines. I mean, it's just there's for the 90s and the 2000s, it was so straightforward. You stored your data in a relational database, and the only choice was which database did you store to. Today, holy cow, there's choice everywhere, and it's overwhelming. It's so overwhelming.
It's completely overwhelming. And when NoSQL or NoSQL came out, I thought it meant NoSQL. But it really means, well, not only SQL, but it's not fun to say not only SQL, right? But what you're saying is, I have a database that is performant enough and distributed enough and powerful enough that I could use SQL if I want. I could use it for document databases. And then you've got things like Redis, key value stores, like the world is just a distributed hash table at scale.
Well, that's the fun thing. I mean, so initially when NoSQL came out, that is exactly what they meant. NoSQL. There is no SQL. There's no query language. So some of the early generations, you had to write your host language code. You had to write Java or C# to walk through the records, kind of like what you did back on the Palm Pilot way back in the day. And then, people, database developers stopped and said, we could adapt SQL. We could create a query language for these other shapes of data, and we can make it work. Right. And that's basically where Couchbase, the direction they took was to say, we're going to take SQL, we're going to adapt it and have it be able to query things from documents or query things from graph or any of the different models that you're storing here. And they're certainly not the only one. I know Azure Cosmos does the same thing. And it's funny because, now, I mean, people will play off of the whole QL thing, right? What is this, a structured query language? Well, technically structured doesn't have to mean relational. It's just not official SQL. Well, but this is still not new, because back during the XML days, when you were talking about introducing XML, Microsoft SQL Server introduced an XML data type into the schema, and it's so interesting to sort of dig in and unpack how we sort of view things and how we assume things about technology based on what we've seen before, right? Because you and I have seen relational databases, and they always had these things. We sort of assume that that's what the definition of a database is. But then you start removing these pieces and saying, data, fundamentally, a database is a pile of data that is more or less opaque in some fashion. And so how it's stored generally is opaque to you, but it doesn't have to be anymore. And how you interact with it is generally through a query language, or you can have an API. And we can have several different query languages. I mean, we're really starting to unpack all of these things that we used to think of this really giant, big block monolith. And now we've got visibility into it. I find it fun.
Sometimes I've gotten in trouble for this analogy because it uses religion as the analogy, but I'll tell you to test this out on you, and you'll tell me. And if we get letters from the audience, we'll see if it works or not. But when I was learning in the 90s how software works, I felt like I was moving through a very religious, dogmatic space. People were telling me, thou shalt do this and thou shalt do this, and you should do it like that. And there were not just theorems, but there were commandments about how to do stuff. And then people would shake those things up, and people would go, that's not good, that's not good. And then it would become the new norm, and then the new commandment, and then people would shake stuff up. So having been doing this now for 30 plus years, I'm starting to get that sense. Now, the reason that I'm saying that for the hopefully the young people, for the career switchers, for the folks that are in a different place in their career, is I don't want them to get caught up in the dogma of whatever religion that they happen to learn when they start, whether that be Ruby or C# or C++. Like, I like C#, so-and-so likes Erlang, so-and-so likes Rust. I don't use what makes you happy. So the analogy that I always use is someone saying, like, don't eat pork. But if you do, here are some great recipes. Like, you can be successful no matter what language you use, no matter what database you use. You might be differently successful, but like, WhatsApp is running on Erlang. God bless them, and Facebook's running on PHP. Amazing.
Well,
good for them.
The thing that I will tell people, as somebody who has, anytime there's a box, I crawl inside the box, then look for ways to get out of the box or break the box, right? One of the things that I was known for 20, 25 years ago is I was one of the few people who knew both the Java and .NET ecosystems well. Back
that is
in the
true.
days.
You were the bridge. That is absolutely true.
Yeah, and in some respects, honestly, I was the ambassador, right? Because I kept seeing things that were going on in the Java space, and I would talk about them in the .NET space, and people would think I was brilliant.
Do you remember the Star Trek original series episode where these guys have one side of their face is white and one side of their face is black, and they're arguing, and they fight, and they have a war, and they're freaking out, and then we don't learn until the end of the entire episode that, like, well, no, my face is white on the right, and his is white on the left. That's what I felt like during the Java versus C# wars, is that, you're literally brothers.
Yep.
Can we just hang out and be friends?
The joke I used to make is that C# and Java were brothers fighting over control of the kingdom, the king, of course, being COBOL. Yeah, I mean, it's
They've diverged now for friends that are listening. To be clear, we're 20 years past that, and there's a lot going
oh my
on, right?
gosh, yes. Oh
But
my
that
gosh, yes.
said, but async and await found its way from reactive programming in C# into JavaScript, and people forget that.
Yeah.
And LINQ as everyone steals from everybody.
Well, and that's the thing, right? People didn't understand people who were listening to the dogmatic stylings of the quote unquote thought leaders of the time. These are best practices, meaning you should do this all the time. Personally, I hate that phrase, best practice. I think, frankly, there are patterns, solutions to problems within a certain context that have certain consequences. And patterns are intrinsically language independent, platform independent. And one of the things that I have found personally over the years, is knowing. So my background being from liberal arts, international relations, one of the things they will teach you is learning another foreign language opens you up to understanding, more cultures, but also understanding your own better. And I have found the same thing to be true about programming languages. If you currently know C#, learn Java, and you will discover things about C# because Java either has them differently or it doesn't have them, or it has something that you think is better than what's in C#. But you understand C# better. And then when when you've learned, a statically typed object-oriented programming language like C# or Java, go and learn something that's functional, right? The pragmatic programmers, Dave Thomas, Andy Hunt, used to talk about learning a new language every year. I open that up to say, learn new tech, right? Learn something new every year. Even if you never actually use it in any production capacity, learning it will only make you better for what you're doing currently. And learning it here doesn't mean you have to be able to quote the specification.
It's how they always say, like, if you can, you should travel and meet new cultures.
Right.
That's what you're advocating for.
Exactly.
That's
exactly
all you're
what
asking
I'm
for.
advocating.
Like you got to understand that if you grew up in your little town and everything, all the sum total of all human knowledge came from your little town, it's probably not the only way to be successful. So
Right.
travel.
Right. And so, I really felt this back when, going back to data for a second, back when the CAP theorem was new and we started looking at some of these, alternative databases. Great. Okay. Even if your IT vice president doesn't trust MongoDB, worth a hill of beans, or if they don't like this notion of key value stores, being familiar with what they look like, how they work, opens your mind up to new data design possibilities, right?
Okay, well, let me ask you this though: if I
Yeah.
go and use a Couchbase or a NoSQL database that's got that promises to be good at everything, is that possible? Because I always use the Swiss Army knife analogy, where it's kind of like it's lousy at everything. Can
So
these databases be good at everything?
so this is where we are in a better position to be able to answer some of this today than we were, say, 20 years ago. Because the whole notion of open source means that we have better opportunities to go take a peek and to see how the database is implemented. But a large part of this has, essentially, how does the data model, the way in which we think about the shape of the data, is it in relations, tables? Is it in graphs, nodes and arcs? Is it in key value? How does that relate to the storage engine? Because most databases actually store all their data in a, similar construct called a B tree. And what they do is they map that storage format over to the different data models. And that's where really the performance question is going to come into play. How well do they do that mapping? And the other part of this is if you want to try to store to more than one database at a time, right? If we call this a distributed database. So if I want to store to a cluster of 3 different databases, where do they put that data? Because moving data from one machine to the next is extraordinarily complicated, right? Imagine it not like I'm going to hop in a plane and fly to Paris. No, it's more like getting on board a cargo container and steaming your way across the Atlantic. It's that relatively slow. So, what do you try to do? You try to localize as much of the closely related data as possible. And sure enough, you pry open the hood of any distributed database and find that there are ways to do this. And they generally call it, things like clustering or sharding or any of those sorts of terms. But now, especially when we start talking about these cloud hosted databases, right? Yes, that's great. I don't have to worry about how the data relates to the machine, but now I also don't get to see how the data relates to the machine. And so in some cases, it has more to do with the storage engine than it actually does the shape of the data or the query language you're using or any of that kinds of stuff.
That seems kind of challenging, though, because that means that if I'm a company that's evaluating a database or a database vendor, I'm going to be probably looking at their SDK, which is several layers of abstraction away from the storage engine. And when I do my formal evaluation and give it to the CTO, I'll say, yeah, their demos are good, their docs are good, their SDK is great. And the CTO might say, yeah, what about their storage engine? I don't know. That's about 6 layers down. I'm sure it's lovely.
Well, this is where, frankly, the way most of us, and I don't mean people new to the industry, I mean people who have, gray in their beards like me. Most of the time when we approach doing a prototype, we do it wrong, right? We look at the prototype, and in many cases, what we do is we replicate the company's demo. And in fact, really what the goal should be is take the thorniest, knottiest, most difficult problem that we face and abstract that out. So if we really want to see how this behaves because we're interested in scale, we have to artificially create a scenario where we're storing data at scale and test that, not just can it store 10 records. I mean, SQLite, the embedded database you referred to earlier, it can store 10 records extraordinarily fast. So if we're doing a performance shootout, SQLite's going to win for everything. But if we start talking about how to do relational data across a 10-node cluster, right, now all of a sudden each of those records is in a different machine and we have to gather them back together. You've got to make sure the prototype that you're building accurately reflects the problem that you're trying to test for. And so if the CTO says, well, how does it deal with scale? There are two approaches. One is dive in and see if you can find the storage engine and, examine how it's implemented. The other way is when you build your prototype, make sure it reflects the CTO's actual concerns, which is, will we be able to store 10 million of these across a 10-node cluster? Right? That's the key.
And also thinking about and this is silly, but the physics are a thing, right?
Mm-hmm.
So where are your nodes? And if you're going to be doing network, operations and partitions, do you have one in Japan and one in Chicago?
Right.
The speed of light is a thing. So, we didn't think about that stuff when we were doing these things in the 90s because we didn't have that level of distance and we didn't have that level of speed. We didn't have fiber optics.
Yeah. I mean, so back in 1995, I was working for a company called Access Health. Doesn't exist anymore, kids. It's been bought like 3 times since. But this was a company that was spinning up a call center of nurses so that, insurance patients, in other words, if you were on Blue Cross Blue Shield, they gave you a phone number and you will dial in to talk to an advice nurse who was one of the Access Health nurse employees sitting in a call center. And we had 3 call centers, one in basically each of the time zones in the United States. We had Sacramento, Chicago, I forget where the East Coast one was. I think it was North Carolina or something. And we were, of course, tracking calls, right? Tracking timestamps on each of these. And one of the things we ran into very quickly is the timestamps were all localized. So I was calling into Sacramento at 9 a.m. and you would be calling into, Raleigh, North Carolina at the same time, but it's 12 p.m. out there. And that made for some interesting problems because, strangely enough, with distance comes different time zones. And that was the first time I'd ever run into a situation where the data wasn't completely localized to where we were sitting, right? And of course, today, worldwide, the reason we had these separate call centers was so that everybody was operating off of relatively localized data, and we weren't having to go over these very expensive T3 lines to communicate between the data centers. It's a problem. It's a major thing. And you can't change the speed of light. Nobody can change the speed of light Although if anybody can, my bet is on Intel. They've broken so many other laws that we thought that they were going to have to, well, they'll never get chips up past 1 gigahertz. Intel says, hold my beer. Here we go.
One thing that I feel like you can change is the business requirement. And I remember I was working at 800.com. It was literally 800.com. It was pre-Amazon, and we had this deal that was 3 DVDs for $1. The president or the CEO at the time wanted real-time inventory.
Mm-hmm.
So we took real-time inventory as go to the inventory database every single time. But real-time inventory was really plus or minus 15 minutes. So simply putting caching just changed the entire characteristics and the behavior of the application, because we just changed the business requirement. In real time, enough, right? 5, 10, 15 minutes. That's all we need to do, right? Because no one was packing like sub-millisecond packs, right? And if we were off by 1 or 2, it was okay. We didn't want to ship 100 DVDs we didn't have or whatever. But by changing that business requirement, and real time is a myth, that changed our application.
Well, and this goes back to some of what we were talking about with the data storage too, around transactions. Because way back when we talked about ACID transactions, right? Atomic, consistent, idempotent, and durable. The poster child for why we would do this to make sure that the data was always consistent and available was banking. Right. If I'm paying you back for a lunch at Chipotle that you bought for me, okay, we're going to deduct the money from my account. We're going to credit the money to your account. We're going to do the whole thing under transaction, because if either one of those fails, the whole thing should fail, because this is money. And the fascinating thing to me, I preach that religiously to people when I was talking about transaction. Got to make sure the database is always consistent. And then I come to find out later that that's not actually how the banking system actually works. They don't use transactions, because to try to do something that takes locks across 2 different institutions and could easily take days.
Yeah. Right. Transactions in banking is always in air quotes.
Right. Exactly. And that was itself eye-opening. I mean, anybody who's ever flown commercially has seen this eventual consistency show up, because you stand there at the gate and the gate agent says, if there's anyone who has flexible travel plans, this aircraft is oversold, meaning they sold more tickets than they have seats on the plane. Because, the airlines, they just grabbed the first plane that was available and said, yeah, we're going to fly this one off to Paris today.
Never understood how they can oversell a plane. It's like that Seinfeld episode where he goes to Enterprise Rent-A-Car and he's like, I have a reservation. And she's like, we have no cars. And he says, but do you have a reservation? The reservation means you hold the car. Like you have to have a car. That's by definition. Like if we don't agree on what a reservation is.
Right.
It's like if I have a seat with an assigned seat, and I don't have a seat, then we have nothing to talk about, right? Then society itself breaks down.
You see, this is the fun part, where businesses will sometimes play some games with the semantics, and normally they get away with it because airlines figured out a long time ago that if there's 137 seats on that 737, we can probably sell 145 tickets, because 8 people on average don't show up because of all this data analysis, data science, etc. But then when that party of 8 actually does show up, yeah, we have to give everybody like $500, $600, $700 travel vouchers. And yet they still make money doing it, because otherwise, if they were losing money, they'd stop doing it. Reservation doesn't quite mean what we thought it did, but this is all part of the wonderful world of eventual consistency. And frankly, everybody uses it. I mean, even Amazon, when they show you the number of copies of a book on their webpage, that number is not accurate. It's close, but it's not down to the actual physical copy. That's true of so many things. Car reservations, hotel reservations. I checked into a hotel about 12:30 midnight one night and discovered that my reservation for the hotel room wasn't. They literally had no room for me. They had to send me to a competing hotel about 15 minutes away. I'm like, okay, this sucks.
That's the worst feeling. That is a very scary feeling. The am I sleeping in the rental car feeling.
Right, exactly.
Because of some database problem.
Exactly.
So what's our advice as we close out our show here? What's our advice to the early in career or the person who's got a couple years in? My advice is to tell them that they should study history of computing, and they'll learn a lot, and it'll make them a better technologist.
I think history is important, but in some cases, the history of computing is hard to find. I mean, there are a few books, right? Conference proceedings, right? The history of programming languages. I've got a couple of those on my shelf, but it's not like they're easy to find. What I would suggest as kind of a practical approach to this, though, is go look at things that are different from what you're using in your day job, right? Learn a new programming language, but learn one that's really different. If you use C#, go pick up a Ruby, right? Ruby or Python, these are dynamically typed object-oriented languages because there's some interesting tricks you can
That's
play.
so true. If you speak Spanish, don't learn Italian, right? Learn Finnish, right? Learn Swahili, mix it up.
Exactly. Go learn something that's fundamentally different than what you currently know, because it will open your mind in various ways that you can't predict. And frankly, you will find some of those ideas creeping back into your designs. Because once you start playing around with dynamic languages and you start seeing some of the advantages they give you, you start looking at the C# dynamic keyword in a whole new way. Once you start playing around with document databases, you realize that every time we created a star schema in a relational database, we were trying to do a document. You go, oh, now I get it.
Now you're going to make me go learn beyond select star from books, and I got to go learn Couchbase or some NoSQL database now. You're giving me homework.
This is my gift to you, Scott Hanselman.
Well, your gift to us was hanging out with me on the podcast today. Thanks for doing that.
Thank you, sir.
This has been another episode of Hansel Minutes, and we'll see you again next week.